All right, so number one, yesterday on the notes we learned when you're multiplying radicals, you multiply outside times outside, inside times inside. So 4 times 5 is what? 20 square root. And now inside times inside, so we got 3 times 7, which does give us 21. Okay. Now, one of the things we've been doing, so if you hadn't been here, right, is you got to know how to do a factor tree and reduce a radical. So I can show you after the warm-up one-on-one. But we want to see, does 21 break down? Does 2 go into 21? No. Does 3? Yeah. Obviously, because we just multiplied, right? 3 times 7. Now, 7 doesn't break down because 7 is prime. 3 doesn't break down because 3 is prime. So there's no pairs. So we're going to leave it as 20 square root of 21. I only do this because you want to always check. The problem I get on these assignments is people don't reduce it all the way, so it's technically not right. It's partially right, okay? Now that's multiplying. Outside, outside, inside, inside. But adding is only on the outside. Do not add inside square roots. Cool? So I'm going to add 3 plus 2 and get what? 5 for my coefficient. And then my square root does not add or multiply. So it's not 16, it's not 8, it's still square root of 4. Okay? All right. And then this last one. This can be challenging, okay? But we learned yesterday that you cannot have a square root on the bottom of a fraction, okay? It's one of those illegal activities in math, right? Can't do it. But we know how to get rid of a square root, and it's by multiplying by the same square root, right? So what am I going to multiply here? Times what? Square root of 7, and if I do it on the bottom, we'll do it on the top. Okay? Now on the top, if I have a regular number times a square root, put them next to each other, right? So yeah, 3 square root of 7, and then on the bottom, a square root times itself. And I know everyone's paying attention, especially if you weren't here, so you can write it down, right? Right? Because it's not a decimal. So 3 square root of 7 over square root of 7 times square root of 7 is 7. And again, we always think, can I reduce this more? Square root of 7 is already reduced. 3 over 7 cannot reduce more. Okay. Now, yesterday, I think we were almost done with our notes. So if you can get out the notes sheet from yesterday. I realized when I printed out the copy of the key, the last one I did wrong. So if you want a copy of me doing it wrong, it's over here. So, but who was not here yesterday that needs the note key? Did you already get one of these? Okay. You got it. And on day one, you might have missed some. Did you want this? Okay. Anyone else? Okay. Now, let's look at it here. So we were on this last page where we were adding. It's kind of like number 2 on the warm-up from today. So you're able to add square roots. Remember, you can only add or combine like terms. So the challenging ones for some people is number 4 and number 5. So look at number 4. Does everyone see how we have a square root of 7 and a square root of 5? And they're not like terms? If they're not like terms, see how I just rewrote it? It's not, you can't combine them. Don't add 5. It's not going to be 5 square root of 12 or something. It doesn't work that way. Look at number 5. See how there's 2 square roots that are the same and 1 square root that is not the same. You can only add the same square roots. So 2 minus 3 gave me negative 1. Square root of 3 minus square root of 5. Now the ones we didn't do were 9 and 10. Am I right? So look at number 9. Can I add square root of 2? We're on the notes. Can I add square root of 2 plus square root of 18? The way it is, no, they don't match, right? But does anyone see something we can do with that? Say what? Okay, we can put 1s in front of them, but they don't match. So if you're ever stuck, think, can I simplify? So is there something to simplify? Well, square root of 2 is already prime. but 18 is not. Okay, so always try to simplify any square roots you have. So for my people who hadn't been here or missed Monday or even yesterday, here's how we're going to break down. So 18, factor tree. What numbers go into 18? Always try to start with the lowest prime, 2. So 2 times what is 18? 2 times 9, okay, and 18 goes away. 9, 2 doesn't go into it, but 3 does. 3 times 3. My 3 prime factors of 18 are 2 times 3 times 3. Now, do I have any pairs? Pair of 3, right? I like to cross one out. Okay, 1, 3. Here's why. When we write it, pairs go out to the left, loners stay in to the right. So let's rewrite this as 3 square root of 2. Thank you. So 3 square root of 2 is really square root of 18. But, see how at the beginning we were adding? Okay, so I'll bring that down. Square root of 2 plus 3 square root of 2. Now can I add them together? Now the square roots match. Now I can add them, right? Okay, so I got a 1 square root of 2 plus a 3 square root of 2. What do I get? 4 square root of 2 is correct there. Now, number 10, can I subtract those 2 square roots? Not the way they are, but just like number 9, I want to think, can I reduce one of these square roots? So yeah, 27 breaks down to 3 and 9. 9 breaks down, 3 and 3. Do I have any pairs? Pair of 3s, right? So again, when I write this, if you weren't here Monday, the circled stuff goes out to the left, the loners stay in on the right. Almost done. Okay, so 3 square root of 3. Bring this down, minus square root of 3. Now can I do that? Can I do 3 square root of 3 minus a 1 square root of 3? I can, and I get 2 square root of 3. And if you have a copy of these notes, you'll notice that I wrote it wrong, so my bad, because I added instead of subtracted. But this is right up here on the board, so you can fix it on your notes copy if it's wrong. Now, that's it for the notes. The assignment today is going to have reducing radicals, multiplying, adding, subtracting, and dividing, and rationalizing denominators, all in one page. So, I'm going to hand that to you, do your best, and then for some of us, I might do a little reteach on reducing radicals, okay?